Welcome to IGCSE Survival Kit by AZ. Subscribe now and survive IGCSE. Welcome back, IGCSE warriors. How are you all doing? You all must be worried about your tomorrow's paper 6 exam for physics, May-June 2025. Don't worry, I got your back. Today we will be going through the last minute tips. This is the guidelines PDF which we were discussing in our previous video, which was made for the tips for paper 6. And we basically didn't complete it, so today we will be completing this. And because it is a very good PDF and a very important one, because it has all the common questions that the person requires, all right, for every topic, and it's really helpful. So please stay focused and all the best for your exams. Trust me, you all will cook in the exam. Just grind today, okay? Lock in for today. I'll give you some tips of what you can do today to get the maximum marks you can in paper 6. Okay, so I believe we are done till here, okay, in that video. So let's start with this now. General physics, simple pendulum. A very important one. You should know how the pendulum moves. So how do you do it? You basically set the pendulum in oscillation. All right, you first mark the mean position using what you say basically in mark schemes. It's said a fiducial aid. Okay, a fiducial aid, whatever. Okay. Please bear with my handwriting. Okay, so you call it a fiducial aid. So you mark the mean position of the pendulum and then you set the bob in oscillation. Take the bob to the mean position and then you release it. When the bob crosses the mean position, okay, when the bob crosses this mean position in one direction, it crosses, right? It crosses in one direction. Start the stopwatch. And then when the bob again crosses the mean position in the same direction, stop the stopwatch. So you start it when it goes here and you stop it when it comes back here. Okay, so this is how you do the experiment for the pendulum bob. Okay, so let's see what is the aim of this experiment: to investigate the effect of length and mass on the period of a simple pendulum. So what are we going to be changing? The length and the mass of the pendulum bob, of course, and length of this string. All right, you should also know very well how to draw diagrams, because they usually say, right, we discussed before, they say a may draw diagram, or sometimes they don't say a may. So please read the question carefully. May is just an option. When they say you may draw a diagram, it's an option. If you have time, you may skip it that time, but after completing the whole paper you can get back to that question. Okay, and if it is, read the question carefully. If it is you have to draw a diagram, then you have to draw. It means like it has marks. You don't have any other option. Okay, so support strand string to metal bobs of different mass meter rule scales. Support stand string to, okay, metal bobs of different mass meter rule scales. Okay, so these are the apparatus which we are using. Support stand, okay, this is the support stand which we are using. All right, then what else are we using? We're using a string, a metal bob, a pendulum bob, okay, and a metal plate, and of course different mass meter rule scales. Okay, now next, what is the procedure? You might have to you have to plan an experiment, so make sure you know the procedures for all these experiments which we will be discussing. Please listen carefully. Okay, measure the length of the pendulum from the point of support to the center of the bob. Okay, from the point of the support means this is the point of the support, okay, and to the center of the bob means over here. All right, so what are you going to do? You're going to measure this length, and then from the point of support to the center of the bob, repeat measurements and calculate average. As we discussed before, this is a must in your answer for paper, for the 7-mark question. Repeat and calculate the average. It will give you a free 1 mark. All right, if you say this, anyone plotting the graph, you must know where to plot the graph. We have already discussed all that before in our previous video. Okay, measure the time taken for the bob to make 10 small angle oscillations. So you account for 10 oscillations. Again, repeat the measurement and calculate the average. Work out the period T, it's the time basically, okay, of the pendulum. This is the time needed for 1 oscillation. So how are you going to work out? If you know, for example, that for 10 oscillations, you can use the proportionality method if you can't do it the other way. Okay, for 10 oscillations, for 10 oscillations, the time taken is, for example, 1 minute. No, it can't be 1 minute, okay? You can say 2 minutes. 2 minutes. So for 1 oscillation, how much is the time going to be? So you do cross multiply. 10x is equal to 2. So x is equal to 2 divided by 10. Okay, got a lot of messy here. Okay, so 2 divided by 10, that's how you find the time period for 1 oscillation. So you basically divide the time by the number of measurements you take. Okay, 10 is basically to improve the accuracy and to reduce the percentage error. We'll see those questions now. Okay, measure the mass of the pendulum bob. So first you did it with Yeah, with the length of the bob. You measure the length of the bob. Now you measure the mass of the pendulum bob, and you repeat steps 1 to 4 with a longer length. Okay, and when you're changing the length, you will keep the mass constant. I think we have done this question before in our previous video. Okay, that's fine. Let's just do it. Okay, repeat steps 2 to 4 using a heavier pendulum bob. Now you will keep the length constant. Okay, when you're changing the mass. When you're changing mass, you keep the length constant. Here, L is constant, and here the mass, M will be constant. Okay, and the same pendulum length was used in step 5. Yeah, I told you that before. Okay, you keep the length constant. Now, precautions to improve the accuracy or to give more reliable results. They usually ask this question. Okay, so no air currents in the place. We have already discussed this. What's going to happen if there are air currents? This is a pendulum bob. Air currents will cause it to swing more away from the mean position. All right, which we are expecting. Next, take the time of number of swings, then divide the time measured by the number of swings to get t. We have already discussed this. Using the proportionality method, you will do it. Okay. Repeat and take average. Very important. For every experiment almost, you will write this. Look perpendicular to the ruler while measuring the height. Of course, you need to look at right angle. Okay, by now, everyone must be knowing. You will look at right angles. Keep the line of sight of the eye perpendicular to the scale reading to avoid parallax error. Please learn the sign. Memorize it. Or understand it as well. Okay? Okay, so memorize this line. Understand it as well. That keep the line of sight of the eye. I'll write it here. Okay? Keep. Trying to write broken handwriting for you all. Keep the line of sight of the eye. Okay? Perpendicular. Perpendicular means at right angle. All right? What the hell? Okay. Perpendicular to scale reading. Why? To avoid parallax error. Then you can add here to avoid parallax error. Okay? So learn this line by heart. Keep the line of sight of the eye perpendicular to the scale reading. And the reason is to avoid parallax error. Okay. So this is how you do it. If they ask you to draw a diagram, just draw the eyeball. Okay, whatever. Anyways, look perpendicular. Okay, discussed already. Use a set square as a horizontal reference. Right? You will keep the ruler to check if it's vertical. You will use a set square. Okay, next. Yeah, we discussed this before. Also, you can use a protractor as well. What the hell? Okay, you can use a protractor as well. And the 90-degree edge of the protractor should coincide with the vertical edge of the rule. Okay? Now, meter rule should be close to the pendulum. Of course, if it's far apart, how are we going to read it? Then measure the length from the center of mass of the bob. From the center of mass of the bob, like I showed you before, right? This is the length we'll be measuring. From the support to the center of mass of the bob. L. Okay? This is the length we'll reach. Loser. Haha. Okay. So, okay, now, conditions kept constant to fair comparison or to repeat the experiment. So what are the conditions you'll be keeping constant? Again, they can ask you this in 1 mark, 2 mark, or even in 7 mark if you're planning the investigation for this. So you will need to say it. Okay, same stopwatch, of course. Same type of stopwatch, okay? Release the bob from the same height, that is same amplitude. Otherwise, it might take time to come back to the oscillation. And of course, it wouldn't be fair. Then, same number of swings. Okay, same shape of the bob, same size of the bob, because of course that will affect how it moves, how far it moves, how quickly it comes back. So these are the factors that have to be kept constant. Same stopwatch, same amplitude, same number of swings, same shape of the bob, same size of the bob. Okay. All right. Okay, so now most important part. Okay, so now the most important part, the common questions. Okay, explain why measuring time of 20 swings rather than 1 swing is more accurate. Okay, it reduces the effect of the reaction time. Okay, because sometimes when you will set the pendulum in oscillation, when it goes here and here, like when it comes back here, so in stopping the stopwatch, there might be the human might not react so fast, right? It might go here and then the person stops the stopwatch. So it won't give accurate results. So if you take it for 20 and then you divide it for 1, like you find it for 1 using the proportionality method, so it will give you more accurate results. I hope you got my point. Now, it will reduce the effect of error like we discussed right now by reducing the effect of reaction time, and time of 1 swing is too small to be measured. Okay, the time for 1 swing is too small to be measured. Like it will go here and then come back here and here. It will be too fast, so the person there might be problems. Okay, now next, why measuring the time of 200 oscillations? Like first they told about 20, now they're telling for 200 oscillations isn't suitable. Of course, the pendulum may stop in between And the student may lose counting, like they're counting how many swings, 1, 2, 3. Of course, 200 is a lot. So the student may lose the count. All right, I hope you got it. Next, suggest a practical reason why the result obtained from the experiment is different. Okay, they're telling that the result we got is different from what should be expected. The reason can be the student didn't react quickly when the pendulum started the reaction time, as we discussed before. Then difficulty to measure the length from the center of the bob. Okay, so the length was not measured accurately, so the results are not the same as we wanted for this experiment. That was to investigate the length and mass of the simple pendulum bob. With this, okay, we have more. Okay, now, suggest an improvement to the experiment. Again, very commonly asked question. Repeat and take average. Very important. Remember this. You can also add and compare, because sometimes the mark scheme requires that. Okay, and compare. Sorry, my handwriting. I know it sucks. Okay, use different lengths. Of course, repeat with different lengths. Okay, and then use fiducial mark. Okay, I said fiducial aid. Here's fiducial mark. Okay, just stick to this. All right. Then draw a graph for the results to find the anomalous result. This can also be to reach a conclusion in the 7-mark questions. All right, this is obviously a plot a graph. Okay, so remember this. What are the improvements to the experiment? Repeat and take average. Use different lengths. Okay, fiducial mark and draw a graph. Common questions already we discussed. Remember to count. Okay, next now. Next experiment. Okay, remember this. Keep the line of sight of the eye perpendicular to scale reading to avoid parallax error. Next, balancing a beam. All right. Let's just change the color, to have more fun. Okay. Now we are balancing a beam. What we're doing is we're placing the pivot here and we're keeping the ruler on top of this. Okay, and then we're placing the blocks and we want the ruler to be uniform and balanced. Okay. So let's see this. Aim. What is the aim? To measure the movement about the pivot and show that there's no net movement on a body in equilibrium. The moment, what is moment? Moment is force times so moment is force times perpendicular distance from force to pivot. From force to pivot. Okay, we have already studied what is moment. All right, so, okay. So now, the moment of a force is a measure, okay, it's already written here, the moment of a force is a measure of its turning effect and is given by moment is a force times distance. Okay, the force is the turning force, okay, acting on a body, and D is the perpendicular distance of the line of action of the force from the fulcrum. What is the fulcrum? The fulcrum is the pivot. Okay, the pivot. Now, for a body in equilibrium, the law of momentum states that the sum of anticlockwise moment about any point equals the sum of clockwise moment about the same point. All right, we already know this, right, from theory, that the sum of the anticlockwise moment is equal to the sum of the clockwise moment. You must have studied this for theory. Next, what are we measuring here, by the way? We are measuring the moment of about a pivot to show that there's no net moment on a body in equilibrium. That is when the total upward force is equal to the total downward force. Okay, now apparatus is as shown in the figure. We'll be using this apparatus. Okay, procedure set up the apparatus as shown in the figure. Okay, you can use this when they ask you the 7-mark question. That you can say that set up the apparatus as shown in the figure, especially if they have given the figure. All right. Next, difficulties and how to overcome them. What can be the difficulties? Balancing the ruler above the pivot. Basically, it's very difficult to balance the ruler above the pivot. So what you can do is repeat several times until it balances, and you can add here that check the balance point. Okay, check the balance point. Don't write BP. They'll think it's blood pressure. Okay, write balance point. All right. Great. Okay, next, the mass slips over the rule. The mass which you keep over here, all right, this load X and mass M, they can slip over the rule. So what can we do for this? Stick the mass with a ruler. Okay, stick the mass with the ruler. You can maybe use a clue. Okay, so just stick it with it. All right. Now next, the center of mass of the cylinder may not above the correct mark. Center of mass of the center may not above the correct mark X. The center, what are they trying to say here? Oh, okay, so they're telling that the center of mass of the center may not above the correct mark X. This center of mass of this ruler may not be above the correct mark. Okay? Like the center of mass of this load, I mean. Alright, this might not be at the correct mark which we are requiring. Okay? So what you can do for this is that measure the diameter of the cylinder. Okay, this lower actually. I think that's what you're trying to talk about. Okay, so what you do is that you measure So like if the node is replaced with the cylinder, so what you're going to do is that you're going to measure the diameter of the cylinder. Wait, I'll show you. Okay. So this is, you have a cylinder. Okay. Bad drawing, I know. So you measure the diameter of the cylinder. Okay, you measure the diameter of the cylinder and then you calculate the radius. Okay, radius is d divided by r, half of this. All right. Then adjust the cylinder above the mark x so that one side of the cylinder at mark x minus r and the other is x plus r. So basically, if you have ruler and you want to keep it at like 20 centimeter mark, if you want to keep the cylinder at 20 centimeter mark, you will keep the cylinder and you will keep it in such a way, okay, you'll keep this cylinder in such a way over here that this mark of the radius, let's consider it as 5. Okay, this radius is 5. All right, so they're telling, okay, so they're telling that it should be in such a way that this 20 plus 5, this point should be 20 plus 5, and this point should be 20 minus 5. So that is exactly at 20. So x minus r and the other should be x plus r. I hope you all got this. Okay, next. Oh, they've shown it here as well. Okay, so if you want to keep it in the middle, this x point, so x plus r should be here and x minus r should be here. R is the radius. All right, and they have shown how they have done it here as well. Okay, in real life. Now next, how to improve the accuracy? Always, I told you, you will repeat and take the average. Look perpendicular, again, very common. Look perpendicular at the scale of the ruler while taking your readings. You can also write this line. Wait, I think I wrote it here. Yeah. Keep the line side of the eye perpendicular to the scale reading to avoid parallax error. You can write this line or this line, whatever you find suitable. Okay, the range of the masses. Okay, you can keep changing the range of the masses to improve the accuracy of the experiment. Next, what is the mass of the ruler? What is the mass of the ruler? Okay, so what is the mass of the ruler? From 100 gram to 200 gram, you can write any value. Now, where is the position? Where is the position of the center of the mass? It is the point at which the meter rule balances above the pivot, right? So where is the position of the center of mass? Like the point at which the pivot balances the ruler, that is the position of the center of mass of the meter rule. Okay, next. Spring constant, Hooke's law. Very common nowadays. It's asked very commonly. Okay. Aim to investigate Hooke's law for a spring. Okay, what does Hooke's law state? Hooke's law states that F is equal to Kx, okay, where F is stretching force, X is the extension of the spring, and K is the spring constant. I like to remember this. So F is directly proportional to the extension. The force is directly proportional to the extension. So that's how we get this formula, F is equal to Kx. Okay, now next. Retort stand, the apparatus is needed. Okay, we can see here we use a retort stand to hold this. And then we use clamp stand. Okay, the same thing. Spring hanger over here. Okay, with 100 gram weight. Okay, it's 100 gram weight over here and with the tape tied. Okay, now what is the procedure? Set up the apparatus as shown in the figure. Fix the ruler vertically next to the spring so that it can be used as a scale, so that you can measure the, you use the scale next to the spring so you can measure the length of the spring. Okay. Okay, I missed this point. The law should hold if the spring is not permanently stretched, okay? Because as long as this is directly proportional, Hooke's law will apply here, okay? When the spring goes beyond the limit of proportionality, as you studied in paper 4, that is beyond which this will not be proportional, that's the point when Hooke's law will not be applied. So basically, when it's directly proportional and when it exceeds that, it will either go like this or like this. Okay, so this is the limit of proportionality, and above this point, the Hooke's law will not be applied. Okay, wait, yeah. Okay, next. Okay, we discussed this. Fixed rule vertically, okay. And how can you ensure that the rule is vertical? Okay, how can you ensure it? You will use a set square, or you can also use a protractor, as we have discussed before. And the 90-degree edge of the protractor should coincide with the vertical edge of the rule. Okay, now if you got the position of the bottom, okay, wait. Yeah, record the position of the bottom of the unweighted spring on the scale LS and repeat your measurements. So without any weight, first you will record the length of the spring. Okay, without any weight, using a ruler. Okay, you will read it perpendicular. Keep your eye perpendicular and you will check the length of the spring. Okay, then measure the length of the hanger L0. Okay, measure the length of the hanger. You'll measure the length of this hanger. Okay, they're talking about this hanger. And then you measure the length of this hanger. Okay, first you measure the length of the spring and then the hanger. Hang an unweighted 100-gram hanger on the spring and record the scale position on the bottom of the hanger, and then you will record the scale position at the bottom of this hanger. All right? So this is to basically check the measurement. Repeats and 100-gram mass in the, okay. Yeah, and record from the bottom of the hanger and 100-gram mass to the hanger, and again record the scale position at the bottom of the hanger. Repeat with step 5 with 200-gram, 300-gram, 500-gram masses on the hanger. So basically you're changing the mass and you will check how much this hanger will go down by reading the bottom measurement, okay, with different masses. All right, plot a graph with the stretching force against the x-axis, along the x-axis, against extension on the y-axis. Please note what you'll take on the x-axis and what you'll take on the y-axis. What you are changing will be taken on the x-axis. That is the independent variable. We already discussed this before. What you are changing, okay? And what you are measuring is the dependent variable. What you are measuring, that will be on the y-axis. Please note this down somewhere and remember this, because it will help you in the 7-mark plan and experiment question, because this is another gain of 3 mark after the repeat and average. Okay, then you'll calculate the gradient of the graph. Why you calculate the gradient of the graph is when you take basically, okay, when you will take the force on the x-axis, the stretching force, wait, let me just redraw it. Okay, when you'll take force per Newton on the x-axis and the extension per meter or centimeter, whatever, and your line will go straight horizontal. So you it will go straight line passing through the origin if the base hooks will, of course. So for calculating the gradient, you will draw a triangle, okay, and draw it as large as possible. We already discussed this before in our previous video. And then you will find the gradient. And that gradient, what is gradient? How do you find it? Please make sure to write this. This is another mark. y2 minus y1 divided by x2 minus x1. Don't just write your final answer. Write this as well. Okay. You're doing y2 minus y1. That is extension. You're doing extension over the force, right? Extension over the force to find what? The gradient. All right. But what is k? K is equal to f over x, right? K is equal to force over extension. If you use this triangle method, f is equal to kx. Right? So k is force over x. So to get the spring constant, what are you going to do? You're going to do 1 of g. Okay, so whatever value you get over here, you'll do 1 of g to get the spring constant. All right, I hope you all got this. Okay, now moving on to the next part. So over here, yeah, what we're doing is we're basically finding the spring constant. Okay, another thing I wanted to discuss with you all in this type of question is that whenever you're finding the extension, like for example, with no load, with 0 Newton, okay, let's just make a table over here, okay, with this is force per Newton, and this is the extension per meter. Okay, this is how you make it. Extension, right? The full, don't just write E, okay, extension. I'm not writing it here. Okay, so if you are taking 0 Newton, and you want to check the extension, what's the extension going to be? It's going to be 0, right? But you can add a column here, length of the spring per meter. Okay, so for example, the length of the spring is 20 with, let me change the color. Okay, it's 20 with a force of 0 Newton. Basically, there's no force. Extension is, of course, going to be 0, and the length is 20. So for 2 Newton, how much is the extension going to be? Can you all tell? If the length is 30. So you're not going to do anything, but just subtract this 30 with 20. So we'll get it as 10. Then again, if for 3, it is 40, okay, and you're going to find the extension. So you're going to subtract this 40 with the original length, 40 minus 20. All right, so 40 minus 20, what are you going to get? 30. Oh, no, sorry, it's 20, okay. So you will get 20 extension here. So what my point of doing all this is to explain you that you will always subtract the length with the original length. Some students, they subtract 40 with 30, 40 minus 30. That's wrong. You can't do that. You will subtract 40 with the original length with no load, because you have to find how much it extends with a load of 3 Newton compared to the 0 Newton. Okay, I hope you all got my point. Okay, handwriting kind of shit, I know. Okay, now going back. Okay, difficulties and how to overcome them. The clamp retort stand might topple. Okay, the problem is, let's just erase all this so that we can discuss. Okay, this clamp retort stands, okay, it might topple over. All right, that's what they're trying to say. Then to overcome, use small loads. All right, what you're hanging the hanger, use it small. Spring might overstretch or spring too weak. Use loads that don't overstretch spring. Don't use too big loads. So these are 2 difficulties that you can face. Okay, they can ask you this in 1 or 2 mark questions, so make sure you know that. It may topple. The reason is that you use small loads, okay? And loads might be too big. It's basically about loads. Loads too small or loads too much. Loads too much, spring will overstretch. Loads too small, clamp retort might topple. So make sure your load is suitable. Next, possible causes of inaccuracy. Spring extension is not uniform with the load. That is, it's not following Hooke's law. This one is not following Hooke's law. Spring exceeds the limit of proportionality, as we discussed before. So these are 2 possibilities of inaccuracy. What are the precautions of safety? Take care with masses and think the hanging masses would fall if the spring snapped. Yeah, so you should take care with the masses, how much mass you're taking, because as we discussed, less mass will cause a retort stand to topple. So a thing with the hanging masses that would fall if the spring snapped. Okay, so take care of the masses, and of course with eye protection. Why? Because if the spring snaps, or if the spring breaks, or if it overstretches, or anything like that, or the clamp stand retort falls or it topples, it might hit your eye, right? Okay, it might hit your eye. So you should wear eye protection. Eye protection, you can write here goggles. Okay. Now next, look perpendicular to the scale. Okay, how you can improve the accuracy or give more reliable results. For these, always there are 2 things you can always write: repeat and average. And usually the perpendicular to the scale can be written. It's most of the time actually. Okay, here repeat and average I think is not written. It should be written though. Okay, anyways, look perpendicular to the scale by taking the readings to avoid parallax error. Alright. Then wait until the spring stops vibrating so that we can get the accurate measurement. Okay. Always measure from the same point of the spring. Right? From the same point, the starting point of the spring. Don't start measuring from here for one and then from here from the other one, so that will give you inaccurate results. Then, ensure that the ruler is vertical. How can you ensure that the ruler is vertical? We have discussed this so many times. Use a set square or a protractor. Bench. Okay, where is this gone? Yeah. Bench surface must be horizontal at least, and bench surface must be horizontal. Of course, it can't be like this or something. Anyways. Okay. Then at least 5 loads for each spring if we're using a graph. At least 5 loads is the least you can do. You should use 5 different loads. Now improve the accuracy by clamping the meter rule in place and then using the set square to measure the length extension. Okay, what they're doing is they're clamping the meter rule over here, and what they're doing is, okay, this is a very good technique. They're taking the set square and they're checking where this coincides with the spring, and then they're checking the value over here. Okay, so this is a very good method you can use to improve the accuracy, because your eye might not read it well, but this will read it very well. Set square. Use the set square to make sure that the clamp rule is vertical, already discussed. Set the clamp rule at 0 centimeter when no masses are added, and so read the extension directly. Yeah, so you can read the extension directly. What they're trying to say is that another way of measuring the spring extension is that you keep the ruler like this, and when you check over here, it's not 0, it's like 4. Okay, it's like 4 over here, or maybe you can consider 8 over here. Okay, then you have to subtract the values to get the extension. Better than that, you can just keep the ruler over here where it is 0, so that over here, so that you can read the extension directly of 8 from here. No, actually it won't be 8, it is gonna be 4. Okay, so you can read the extension, the length directly as 4. Alright, so that's what all they're trying to say. I hope you all got it. Okay. Next, conditions that have to be kept constant. Okay. Same spring diameter. Okay, the spring diameter should be the same spring thickness. See, type of string also you can write. Same range of loads. Okay. Same length of the spring. Length of the spring before starting the experiment, right? It should stay the same for all of them. Same number of coils. The number of coils on the spring should be the same. It's all talking about the spring thickness, spring diameter, length of the spring. Okay, then same coil spacing, the spacing between the coils. Of course, when you draw it also, please make sure I'm drawing it here. It's not coming that accurate. Okay, the length between the strings should be constant. It shouldn't be like this, that sounds so weird. Okay, so just ensure that the spacing is constant. All you can do is try to do that. All right, now easy peasy. Density displacement method. How you can do the displacement method to measure the density of sand. What we are trying to do is we are trying to measure the density of sand. So density is given by the formula. Density is given by the formula mass divided by volume. If we get to know the mass of the sand and the volume of the sand, so we can find the density. Alright. So for a regular shaped solid, the volume can be found by measuring its dimension. Okay. So how will we measure the mass of the solid? Mass can be measured using a top band balance. M is equal to M, like you can find it using a top band balance. Okay, remember this term, top band balance. So how are you going to measure the volume? This is the sand, but for a regular object, you can measure the volume by basically measuring its dimensions, right? Like if you have a square, you can measure the length, the width, and the height, of course. And you can multiply the values. Or if you have a cube, you can just multiply all the values. Again, length, breadth, and the height. Okay, so you can get V is equal to L into B into H. Okay, L into B into H. All right, but for sand, how are you going to do this? Okay, so that's what we are going to see over here. We are going to use something that's called a displacement method. Okay, now let's look at what this displacement method is. For a regular shaped solid, the volume can be defined by measuring its dimensions, okay, as we discussed, and mass is determined by weighing on a top and balance. For an irregularly solid shape, the volume is found by immersion in a liquid. Okay, so before they tell you what it is, okay, let's just go with the method. Okay. Starting with the procedure, you will first measure the mass of the solid material, that is the sand which we are considering here. On a top and balance, okay, I already told you this, on a top and balance you'll measure the mass. Okay, mass is done. We found the mass. Now next step is the volume, which is the main problem because we can't use length into breadth into height. Why can't we use that? Because it's an irregular solid, right? So you can't just measure the length. It's not going to be accurate. Stop considering these spaces in between and everything. It's not going to be accurate. Okay, so how are we going to do this? Is it sand over here, by the way? Okay, they haven't mentioned about using sand over here. It's just solid. It's just an irregular solid over here. Okay, so what are you going to do? You're going to fill the measuring cylinder with the known volume of water V1. Okay, so what you're going to do, do I have an empty space here? No, okay, I'll just do it over here. Okay, you're going to take a measuring cylinder, all right, and fill it with water. And you're going to take the reading of that water from the bottom of meniscus we discussed before. Okay, and this volume of water is what? V1. Okay, this is V1. This is what they're saying. Okay, you fill it with the known volume of water V1. Shank the solid very well. Okay, what they mean here is that shank the solid material really well, like put it inside this measuring cylinder, the same measuring cylinder in which you had water before. You are going to, okay, you had water before, you are going to tie the object with a weightless spring and immerse it completely into the water. Okay, immerse it completely into the water. So what is going to happen here is that this volume of water will increase, right? Why will it increase? Because the mass of solid has been added. So make sure you use a weightless spring so that there's no weight of the spring. Okay, weightless string actually. Okay, and you immerse it into this. All right, so we got the volume of water over here, that is V1. Now we are putting the object and the volume will increase. Immerse the solid in the center. Okay, the technique you should write that tie the object to a weightless string and immerse it completely into the water. Then measure the new volume V2. Now you'll keep your eye perpendicular and you will measure the new volume, that's V2. Okay, this is V2. So now we got the increase in volume. Now we can easily find the volume of the solid as V is equal to V2 minus V1. Okay, if we can find the volume V2, we can subtract these two readings and we get the volume of this solid. Okay, now we have the mass, we already found it using a top and balance, and the volume also we have found it subtracting this. So you can also write it like this: density is equal to mass, this is rho sign, okay, for density, mass divided by V2 minus V1. We got the volume of this. Okay, I hope you all understood this. It's shown here as well. This is the first reading they got, okay, and it's the second reading, V2 minus V1. Okay, next, precautions to improve the accuracy. Shank the solid material, okay, put it completely into the water. Thin string must be used, okay, thin string, and of course a weightless spring. Look perpendicular, as I told you before, look perpendicular to the scale reading. Look from the meniscus, bottom of meniscus. You only look from the top of the meniscus when it's a mercury. Only for mercury. Except for that, all liquids you look from the bottom of the meniscus. Okay, put the solid material gently. Don't put it very fast or very roughly. Why? Because there can be splashes. We'll discuss it later. Okay, there can be splashes which can cause the loss of the water, so the volume won't be accurate. Okay, next possible sources of inaccuracy. We discussed parallax error. Parallax error, keep the line of sight of the eye. Already I wrote it here, right? Yeah, here. Okay, the line of sight there perpendicular to the scale reading to avoid parallax error. Okay, student did not look from the meniscus of the material. From the bottom of the meniscus, student did not look. And the mistake student can do is that the meniscus is here, they look at from here. That's wrong. You need to look at from the bottom of the meniscus. Okay. Next, splashes during immersing the solid material can again be another source of inaccuracy. Okay. we discussed this before. Okay, air bubbles may be found in solid material. Okay, when you put the solid material, there can be air bubbles that can be caused, okay, which can again affect the accuracy of the experiment. String is too thick, okay, it can also cause extra increase in volume, okay, so we won't get accurate results. Slender may not be sensitive, it might not detect that solid is added. So for this, if they ask you slender is not sensitive or anything like this, what you can say is that use a narrow measuring cylinder, because rather than a wide measuring cylinder, because when you put the string, maybe a small volume increase is shown, but in a narrow measuring cylinder, it will be sensitive. It will show the increase in volume. The increase in volume, it will be more obvious. So you can say that a small increase in the reading, why we should use a narrow measuring cylinder, they can ask you the reason as well, that a small increase in the reading of the volume, what it does is that it causes causes the change that is more obvious. Okay, a small increase in reading of the volume is more obvious. Okay, so it is smaller intervals it has. Okay, with this we come to the end of this experiment. Now moving on to the next experiment, cooling rate experiment. Cooling rate experiment. Now, okay, how do this is easy experiment. Okay, we have already discussed this before in our previous video as well. Rate experiment, how are you going to investigate this? To study how the surrounding temperature affects the rate at which water cools. So you're going to check how the surrounding temperature, that is the outside temperature, will affect the cooling of this water, how it radiates heat outside. Okay, so a hot body loses its heat. This is the theory. Okay, a hot body loses its heat energy gradually to the surroundings. All right, the experiment is done by measuring the temperature at equal time. So you will measure the temperature like every 30 seconds to check how much the decrease in temperature is. All right, because it's going to lose heat to the surroundings, so the temperature of the beaker will then decrease. Okay, so the temperature decreases until the body reaches the room temperature. Always remember, they love to ask this question, that what is the temperature? Okay, what is the temperature after it has cooled down? The room, you will always write the room temperature, that is 20. So it's almost like 20. Okay, it's almost like around 20 degrees Celsius. So I think this is mostly asked in chemistry, by the way, not in physics. Okay, anyways, but remember it reaches the room temperature. Now, the rate of cooling of a body depends on two things. Okay, depends on many things actually. The difference in temperature between the body and the surroundings. Okay, the rate of cooling depends between the difference in temperature between the body and the surroundings, like the surrounding temperature and the temperature inside the beaker. Then it depends on the exposed surface area of the body. Okay, how much surface area is exposed? Because the greater the surface area, the more heat it will radiate. This one will radiate more heat. It will cool down faster compared to this one. Let me tell you, this is also a very commonly question asked based on this experiment. Okay, it's very commonly coming nowadays, so please make sure you do it well. Alright, so it will cool down faster. This one will cool down faster. The theory behind this is that the greater surface area is exposed, so the rate of evaporation, okay, more evaporation. Okay, there'll be more increased evaporation, and evaporation causes the cooling of the body. We studied this before because the more energetic particles escape from the surface. Okay, more energetic particles escape, leaving behind the less energetic particles. So the overall temperature of the beaker will decrease, and the greater the surface area, the greater the area, the greater the chance of the body to emit heat, and the faster it will cool down. And the nature of the radiating surface, it's also very important. Dull black. Okay, remember this. I'll write it here. All right, dull black is a good observer, and it is a good radiator of heat, good radiator or emitter, you can say, of heat. Okay, and shiny surface is just the opposite of this. It's a poor radiator, poor observer and poor radiator. Okay, I hope you all got this. Please remember this, because they can ask you questions related to theory as well. Now, the apparatus you need is a heater, a thermometer, a beaker, and a stopwatch. Okay, you need this test tube, you need the thermometer, you need a beaker, and of course you need a stopwatch. Alright, so in the plan experiment, they also ask you additional apparatuses. So if any is not mentioned, you can mention the other one, okay? The details of the procedure may differ from experiment to another. This is the general procedure. Like, because sometimes they tell you what is the effect of surface area. So you will tell use a wider beaker, use a narrower beaker. So, you know, the procedure can differ, but this is your general procedure. Place heater into the beaker and turn it to raise the temperature of the beaker to whatever degree Celsius. Okay, so you place the heater in the beaker and you allow it to heat. Okay, stir the contents of the beaker and place the thermometer into the beaker. You will stir the contents. Why you stir the content? For even distribution of temperature. Okay, and then you place the thermometer into the beaker. Then note the starting temperature and turn on the stopwatch. Take readings of the thermometer and stopwatch at regular intervals. You keep measuring the temperature after like 30 seconds, 40 seconds and all that. Okay, regular interval. You can take mostly it's like 30 seconds, 30, 60, 120, like that. Take readings of thermometer, okay, at regular intervals. Tabulate and plot a graph to conclude your experiment. Okay, conclude is always plot a graph. Now, precautions of safety. Take care when dealing with beakers of hot water. Yeah, because it's hot. Set the hot water in a safe position where they will not accidentally be knocked over because it's hot, right? It can harm your body. Handle with caution to avoid the burns. Of course, it's hot, so it can cause burns. Now, this already be discussed. You should stir it before reading. We discussed it in our previous video, I remember. Okay, keep the thermometer at the same level. Keep the thermometer at the same level for both the beakers because the deeper the thermometer, the more it can cause the, the temperature reading. Okay, set eye perpendicular to scale. Again, you all know what this means. Wait until reading stops rising. Okay, wait until the reading stops rising. And position. Yeah, we have discussed this as well. Okay, position clocks with thermometer and clock can be seen easily. Okay, so that you can see the stop clock easily, and as soon as it turns at 30 seconds, you can measure, note down the reading, and 60, like it should be placed in front of you. Let me tell you, the examiner loves this point and this point. The mark scheme loves these 2 points, but you can write the others as well. Next, what are the causes of inaccuracy and how to overcome them? Heat loss is due to surroundings. Okay, the heat loss can be to this. Heat loss is due to surrounds. Okay, lock the container with an insulator. What it is going to cause? It is going to reduce the heat loss to the atmosphere. Okay, and cover the container with the lid. Of course, again, it will reduce the heat loss to the atmosphere because it will prevent what? It will prevent evaporation. Prevent evaporation. This question was asked. I remember in February, March. We discussed it yesterday. Evaporation. Okay. Then initial temperature near to the room temperature. Okay, the initial temperature, yes, it should be nearer to the room temperature to get more good results. Okay, next, conditions that should be kept constant, very commonly asked, and or to repeat the experiment, measure the water in the test tube or beaker to ensure same volume of water. Okay, volume of water should be kept constant as it is being used each times, as cooling rates are different for different volumes. More the volume of water, it can decrease the cooling rate or increase or whatever. It's usually a decrease in the cooling rate, I believe. Okay, then you use the same starting temperature because cooling rates are different at different temperatures. Okay, same starting temperature. This is the reason. Please remember the reason because they usually ask it that at different temperatures the cooling rates are different. Ensure all water in tube below level of water in beaker. Ensure all water in tube is below the level of water in the beaker. Okay. Ensure all the water in the tube is below the level of water in the beaker to ensure that all water in tube has the same surrounding temperature. Okay. The next, use insulation or lid on the beaker to keep the water in the beaker at the same constant temperature. Okay, we already discussed this. Then same beaker, same thermometer. Alright, because if you use a different wider beaker, narrower beaker, it can affect the rate of cooling. Explanations is written in bold. Okay, italic bold needed in some questions. Yeah, I told you it's needed in some questions. Basically, they give 1 or 2 mark and they ask you why it is like this. Okay, now moving on to common questions. Very helpful. Okay, explain why the rate of cooling decreased by time. Okay, or why the initial rate of cooling is greater than final rate because it's nearing the room temperature. Okay, because the liquid temperature is becoming near to the room temperature. As it is it's becoming nearer to the room temperature, the rate of cooling will decrease. Okay, if you have 2 tables in the question, you need to justify the statement, calculate the difference in a given time interval in each table and compare between the results within the limit of experimental accuracy. What they mean here is that, okay, wait, I'll show you a question related to this which showed up in Feb March so that you can understand this justification. We discussed it in our previous video. Okay, here's this question. So here what they're trying to say is whenever you have to justify, you'll subtract the readings. So here what they're telling is write a conclusion whether the insulation affects the rate of cooling. Okay, and justify your answer by referring to values. So justification is where students mostly go wrong. Alright, we've already discussed this question, but I wanted to explain you what the justification meant is that you will subtract the reading. Okay, you will subtract this with this and this one with this, and you will check which has a greater temperature change. Look, the beaker B has a greater temperature change. Okay, so it cools more faster than the beaker A. Alright, so you'll subtract the readings to find the temperature change. That's all what they mean, and then you'll give your conclusion that insulation reduces the rate of cooling. Alright, so this is all what they mean. Please remember this, justify answer. This is how you're going to do it. You can subtract the readings. Okay. Examples of insulators include glass, wool, cotton, plastic, rubber. The electricity experiment, this is very important, and it has been asked again in March planner experiment questions, so make sure you are familiar with this. So this is the diagram. You should be knowing, as we discussed before, ammeter should be in series, voltmeter should be in parallel. Okay, so now moving on. To measure the resistance of the wire or to investigate its dependence on the length of the wire. So there are two things you are going to measure: the resistance of the wire. This is the procedure. The procedure that's given here, you can use it for two things: to measure the resistance of the wire and investigate the dependence on the length of wire. So you basically keep changing the length of the wire and check what's the resistance. Okay, so the resistance of a wire is given by the formula R is equal to P, where I, they usually give this formula. Okay, they usually give this formula in paper 6, where V is the potential difference across the wire and I is the current flowing through it. Okay, so next, apparatus needed, we all know it. We need a battery. Okay, then we need a switch to switch it on and off. Okay, we need the wire, voltmeter, ammeter. Ammeter is to measure what? To measure the current, that is I, and voltmeter to measure the voltage, that is V. And then we need a meter rule to measure the length of the wire, of course. Alright, mounting clamps so that we can connect it. Then rheostat, 0 to 25 ohms rheostat to change the resistance depending on the experiment, if you need it or not. Now, the precautions of safety are the wire may become hot when current flows in it, so you should keep the current, according to the limits. Okay, precautions to improve the... Why haven't they given the procedure? Okay, I will explain you all the procedure. Just give me a minute because they haven't given it here. Okay, precautions to improve accuracy or to get more reliable results. Again, they must be repeat and take average. Yeah, take several readings and take overall average. Okay, look perpendicular, two things which you can most of the time always write. Okay, now to overcome the heating effect in the wire, use a battery which has a low electromotive force. What is electromotive force? It is basically the voltage. So when the voltage is lower, the current will also be lower. Next, so when the current is lower, basically, the wire won't heat up because more current will heat up the wire. Now, switch on and off between readings. Yeah, because to prevent the overheating, when you will switch it on, when it is working for a long time, it can overheat. So when you off it, it can cool down, and then again, you can continue the experiment. Okay, add a lamp to lower the current. You can add a lamp over here. Okay, you can add a lamp to lower the current. Why will lamp lower the current? The reason is that if you add a lamp over here somewhere, it will increase the resistance. Okay, it has resistance. It will offer more resistance when the electrons move across it. So when resistance will increase, the current will decrease. And when current will decrease, heating effect will decrease. All right, heating effect will decrease. All right. Also, let me tell you, after I explain all this PDF, I want you all to go through it really quickly. And then I'll attach it in the description. You all can go through it really quickly before your exam, 1 or 2 hours, because it's really helpful. It covers all the experiments in your syllabus. You can also watch this video on 2x, so that on 2 playback speed, so that it's helpful for you. Okay, this will be discussed in the end. First, let's continue with this. All right. Add a lamp to lower the current. Okay, I explained to you why it will lower the current. Then sometimes, depending on the resistance, depending on the given diagram, you can increase resistance of the resistor. Sometimes, not a long time, depending on the given diagram, you can increase the resistance of the resistor. How? If you have a variable resistor, okay, depending on the diagram, they also ask you the circuit symbols. Please make sure you do go through all of them. I'll attach it in the description, and we might go through it together in the end. Okay, this is a variable resistor. I've not drawn it so well. Let me try redrawing it so that it's more accurate. Let's see. This is how it will be going, connected. Okay, this is what a variable resistor looks like. In a variable resistor, you can change length. Okay, you can change the length to change the resistance. Change R. So you can basically change the values of R. You can place the length. If you take this much length, it will be less resistance. Like, you can change the length and vary the resistance. Okay, so that's how you can change. Depending on the diagram, you can increase or decrease the resistance. Now, how to improve the accuracy and give more reliable results? Look perpendicular while taking the readings. Tap on both the ammeter and voltmeter to check that pointer is free to move. It's not sticking anywhere. Okay, you can tap it and check it. All right. Then take several readings and overall average. Why is this done? You can identify anomalous results, and reduce anomalous result, and percentage error will decrease. Okay. Always check the connections are clean. All right, they're connected properly, they're clean. Check the ammeter and voltmeter for zero error, because sometimes the ammeter, when you start it, it might be at 2 current. Already a current is flowing to it, or it's like at 2 pointing towards 2. So when the current will increase, you will have to subtract readings, and also it's, very difficult. Make sure it's at 0 before. Okay. Next, initially choose the highest range for the ammeter and voltmeter, then reduce the range so that the deflection is almost full scale. So you change like a high range and then reduce the range so that deflection is like full scale. Okay. Possible causes of errors: heating of the wire. All right. Why? This question, how they ask you, they're like another student does it and he makes error. His results are not same. What is the reason? So these points in the end of the experiment given here will be very helpful for you. Okay, the battery is used up, the battery finishes. Okay, then bad connection of the sliding contact in the variable resistor. Okay, this variable resistor. Okay, so the sliding contact, it has a bad connection. Next. Oh, yes, I told you all that we will be discussing the procedure for this. Okay, so in this experiment, if you have to, they can ask you in various ways. If they tell you have to change the length of this wire, once they ask to change the length of this wire, then what are you going to keep? This constant variable. You will keep the type of the wire constant. You will keep the diameter of the wire constant. You will keep the voltage of the power supply constant. Okay. And to do the experiment, you will set up the apparatus as shown in figure. Okay, we have discussed this type of experiment in March. Shown in figure. Then you will say that any additional apparatus like meter rule, you can say voltmeter, ammeter, if it's not mentioned. Then you will say connect the ammeter in series and voltmeter in parallel. Okay, ammeter in series, voltmeter in parallel. All right. Then you will say switch on the power supply. Okay, switch on this power supply. Then allow the current to flow. Note A and V values, current and voltage. That's how you'll say it. Okay, I'm just writing it here quickly. Okay, note these two values, and then calculate resistance using the formula V over I. Because you can use this triangle, D is equal to IR. Okay, then R is V over I. They usually give this formula, by the way. Okay, and then repeat it for more length of wire, keep all those constant, and plot a graph taking, it's the length of the wire, right? Change the length of the wire using a meter rule, measure it, and then you can mention some values like 20 centimeter, 30 centimeter. They can also ask about the diameter, then you can use a micrometer screw gauge or vernier calipers to measure the diameter of the wire and repeat it. Then you plot a graph taking the length of the wire, per m on x-axis, because that's what you're changing and what you're measuring, and resistance on y-axis. Plot a graph. Okay, and just sort it in a messy way. I hope you all got it. And then you can also say that the table how you're going to draw it is you will take length of wire. Draw it neatly, all right? Per meter. Then draw the roof. Oh my god, so less spaced. Okay. Voltage, you write voltage per volt. And then current I per ammeter. No, sorry, wait. Current per I. No, sorry, it's not going to be I, it's going to be amperes. Okay, current per amperes. And then under the rule, you will add for the resistance per ohms. Ohms, this is the sign. Okay, ohms. Wait, just let me draw it accurately. Ohms. They've given it here somewhere. Yeah, this one, fine. Okay, this one. Okay, so this is how you carry out the procedure. I hope you all got it. You can go through the mark scheme, not the mark scheme, sorry, my video for March. In the end, I have done the planned experiment. All right. Next, optics experiment. Again, very common nowadays. All right, this experiment, the stop on electricity and the cooling rates. It's really common nowadays. Examiners love these questions nowadays. Okay, so how to determine, aim is to determine the focal length and the linear magnification of a converging lens. All right. The parallel rays from a distant object converge towards a principal focus on a converging lens. The torch is not considered, okay, parallel rays from a distant object. They're parallel rays, okay, they come to the lens and they converge at a point. Okay, that's what they're trying to say. Converge toward the focal point of converging lens. The torch is not considered a distant object and is not used in this experiment while determining the focal length. Okay, they're telling the torch is not considered a distant object, not considered. Okay, the first part of the experiment should be performed without a torch, only depending on a distant object. Like, you can't use the torch as a distant object because of course it has light and all. So you will use like maybe the room or the window or maybe a tree outside from the window you can see. You can use that as a distant object. Now, remember, magnification is height of image divided by height of object. Okay, this is the theory. Now, apparatuses that are needed. You need a small torch, you need a converging lens, you need a screen, right? The screen, okay? The screen over here. Then you need converging lens over here, a meter joule, okay? And adhesive putty, okay. Now, what is the procedure? Hold the lens up to a distant window, form a sharp image on the window or screen wall of a piece of card. Okay, you hold up the distant object and you measure and record the distance between the lens and the card and the image V. Okay, you record this distance. Next, what you do is repeat step 1 and 2 and obtain an average value for the distance V, which is equal to the focal length of the lens. Okay, I hope you all got this. Now, next, magnification. Okay, what are the difficulties and how to overcome them? This is also again very commonly asked. This was a question, I think, 2024, May-June. Okay, measuring the dimensions height of the image using a hand ruler away from the image. Basically, measuring the height of the image that is formed, like you can consider a triangle that is formed. It is difficult to measure the height of the image using a hand ruler away from the image. Like if you keep the ruler away from this image, it's difficult to measure it, right? So, and another problem can be overcome. So this problem can be overcome by using a translucent screen that is fixed with the ruler. Okay, if you fix the translucent screen with the ruler, it's going to be easier. All right. Next, what are the precautions? Okay, remember these 2 points, very important. Okay, actually everything over here is very important because these are all the experiment. It contains all the common questions and all, very helpful. Okay, precautions to improve accuracy and to give more reliable results. Again, repeat and take average, like perpendicular, 2 things you can always. These are 2 things which you can always write. Carry it out in a dark room. Object and lens have the same height from the bench. Okay, they should be at the same height from the bench. Imagine like object is at a higher height or something, so it can cause problems. Mark on lens holder to show the position of lens center. You should know the position of the lens center. And object lens screen should be perpendicular to the bench. Make sure you know all of these. All right, moving on to the next common questions. Draw or describe the image. You can say inverted or you can say enlarged if it's magnified, if it's diminished. Okay, you need to see all that. These are the wordings which you'll be using. Then how do you find the magnification? Distance of image from length divided by distance of object from length. And the height of the image or height of the object. These are 2 ways in which you can find magnification. Use formula 1 or 2 depending on the question. All right. So here, what is this? Magnified if image distance is greater than object distance. Of course, this is the object that is placed, and if image distance is greater from the object distance to from the length, okay, the distance to the center of the lens, then it is magnified, and if object distance is greater, then it's diminished. Okay. Why the object, the lens and the screen should be perpendicular to the bench to give a sharp focused image. Okay, I hope you all got this. Okay, this is another laws of reflection. Okay, this has been asked, like, to draw using this ray box diagram is basically asked to draw more commonly. Okay, to verify the law of reflection and identify the properties of an image in a plane mirror. The law of reflection states that angle of incidence, okay, what you're going to check is you're going to verify the law of reflection in which angle of incidence is equal to angle of reflection, and identify the properties of an image that is formed by a plane mirror, like is it inverted, is it same size as object and all, is it all, of course, same size as object. Okay, the law of reflection states that angle of incidence equals angle of reflection, as I told you all before over here. where I is the angle between the incident ray and the normal, right? This is I. It's the angle between the incident ray and the normal drawn to surface at the point of incidence. And the reflected angle is, of course, the angle between the reflected ray and the normal drawn to the surface at point of incidence. Okay, so this is reflected angle. Yes, okay. Next, apparatuses that are needed are a ray box, a plane mirror, pins, protractor, and adhesive. Now let's start with the experiment. Place the plane mirror on a sheet of white paper. Okay, this is the plane mirror. You place it on a sheet of a white paper. All right. Well, oh no, wait. This is the plane mirror. Wait, give me a minute. My bad. This is the plane mirror which is being placed on a sheet of a paper. Okay, so holding it vertical with plasticine or block of wood. Okay, keep block of wood so that it stays straight. Draw a line along the mirror. You will draw a line along the mirror. Okay, use a lamp or slip box to shine a ray of light on the mirror. Because it's the ray of light that is shining, and you use, okay, a slip box. You shine a light of ray to the mirror. All right, then you will see the reflected ray of light. Mark the position of each ray with optical pins. Okay, you will shine the light over here, and then you'll see the reflected light, and you mark the position with optical pin. You put up pins over here, okay, to mark the position of the reflected light. Now, use a protractor or set square to draw a line at right angles to the mirror. This is called the normal. Normal is always drawn to the right angle. Here it's drawn like this. Okay, it's drawn at 90 degrees to the mirror. You will draw it. Then use the protractor to measure the angle on each side of the normal. This is easy. Okay, this is the ray coming. This is the ray reflecting. Okay, I'm just assuming this is the ray reflected. So now what you're going to be doing is you keep your protractor like this to the normal, and you will start measuring from here. Measure this angle. Okay, reflected angle, and if you're measuring this one, so you will keep your protractor like this, and you'll measure till here, instant. The angle of incidence is formed then. All right, next, procedure done. Precautions to improve accuracy and give more reliable results. Common, repeat and find average, okay, and perpendicular. Loop perpendicular, no, this one. Loop perpendicular to avoid parallax error. Keep the line of sight of the eye perpendicular to the scale reading to avoid parallax error. Now, precaution while putting the pins. Very common question. Place the pins as far as possible, not less than 5 centimeters. Remember this, because there was a question in which they were like it's 3.2 centimeters apart. First, they told you to measure the distance and put something like 3.2 centimeters from the two pins. Okay, they were 3.2 centimeters apart. And then they asked you if this is a suitable distance, and you had to say no, they should be at least 5 centimeters apart. Why? To give good image in line. Accurate results, you can say. Accurate results. Accurate, not good image, accurate results. Okay, whatever. I hope you all got it. Next, use more pins. Okay, place the pins vertical. Use more pins. It will improve the accuracy. You can place the pins yeah, you have to place the pins vertical. Okay, because if it's horizontal, of course, it can cause problems. Draw the lines as thin as possible. How can you draw it as thin as possible? Use a sharp pencil. Okay, now use a thin protractor, because of course a thick protractor, and if the readings are not accurate, then look from the base of the pin. No concern about pins being vertical. Okay, look it from the base. The base of the pin lies on the ray. The base is always perpendicular to the plane. Okay, now possible sources of inaccuracy. Again, I told you, they ask you this question. What did another student did this experiment? Well, what did he do that he did not get what was the error which he did, because of which he did not get accurate results? Thickness of the pins were too thick. Thickness of protractor, thickness of lines. Maybe he used thick pencil, thick lid pencil. The lid of the pencil was thick. Okay, you can write that pencil not sharp, or pencil not sharp. Okay, thickness of mirror. Glass on front of mirror causes double refraction. Okay, pinholes. Next, this is about refraction. They mentioned refraction here, although we were discussing reflection. Anyway, now let's discuss about refraction. I think that's the end. Yeah, then there's some questions. Okay. Yeah. All right. Okay, object experiment 3, refractive index. This is the last experiment. All right, please pay attention. To determine the refractive index of a block and observe the pathway of light through a block, you need to determine the refractive index of this block and the pathway of light through this block. Okay, so how are you going to do it? This is the aim of the experiment. Refractive index. Okay, refractive index is given by the formula sin I by sin R. So what is I over here? I is the angle between the incident ray in air and the normal, and R is the angle between refracted ray and the normal. Okay, so you all have studied this in theory when you were preparing for paper 4, of course. Now, what are the apparatus that is needed? You need a lamp, of course, to shine the light, a single slit, glass block with lower surface painted white, and a protractor. Okay, next, place a regular block of glass on a white sheet of paper and trace the edge of the block using a pencil. Okay, you'll place this block on a sheet of paper and you trace its edges using a pencil. Okay, now, what are you going to do? Draw a normal to one side of the block. You will draw a normal to one side of the block. They basically, they don't basically ask you to do all this, like how to do all this, but they give you in most of the questions, if you have done past papers, they give you the block and they ask you to draw the normal. They're like, draw a normal through AB, then continue it beyond CD and all that, This is how they ask you. And it's quite a simple question. We have done it, I think, in Feb, March. Yeah. Okay. Place a regular block of glass. Okay, we have done this. Draw a normal. Let a light ray fall on a point where the normal is drawn. Okay. You let one light ray fall on the point where normal is drawn at this point. Okay. Now, what is going to happen? Observe the emerging ray from the side of the block. Okay, what you're going to do is you're going to observe the emerging ray that's going to come out from another side of the block, maybe from here. Okay, what's going to happen? Okay, so you'll put the pins to determine the path of the incident ray and the emergent ray. You will put the pins, okay, ready to go? Yeah, you'll put the pins over here. Okay, put the pins over here to identify the part of the incident ray and emergent ray. Emergent ray will probably go like, this is the normal, right? It would bend towards the normal, so it will go like this. Okay, something like this. All right, and then it's going to bend out. All right, something like this. So you put the pins to find the path of this emergent ray. Basically, you would put pins like this. Okay, where the emergent rays, put pins here, put pins here. Okay, and again, you will follow all these techniques. In pins are vertical and all. Okay, yeah, it's given here. Okay, wait. Remove the block and draw the lines representing the incident and emerging ray. You will remove the block. Okay, you will remove this block now. You'll take out this block and you will draw the lines where you kept the pins. Okay, wherever it was going, you will draw those lines. Okay, I'm not doing it correct. Okay, you will draw those lines. Now, measure the angle of incidence and angle of refraction. Okay, you got the angle of incidence, angle of refraction. Then you can use n is equal to sine I, where I is the angle of incidence, divided by sine R, where R is the angle of refraction, and you will find the refractive index. Okay, precautions while putting the pins. Again, keep it as far as possible. Use more pins. Pins are vertical. Okay, same as the previous experiment. Draw the lines so that they are thin as possible. Again, you will use for this a sharp pencil. Sharp pencil. Even in your exam, if you're given a question, this question, I love such type of questions. I wish it comes up for you all because it's going to be better, right? It's an easy question. So you just need to draw lines and make sure your pencil is sharp. You can take 2 or 3 pencils and yeah, or you can keep sharpening it regularly. Okay, again, yeah, look perpendicular to avoid parallax error. Use 10 protractor. Look from the base of the pin. No concern about pins being vertical. Okay, base lies on the ray. Base of the pin lies on the ray, right? Okay, the base of the pins tell you the line of the ray, the way the ray goes. The base is always perpendicular to the plane, of course. Repeat and take the average, thickness of line, source of inaccuracy. Now, we've already discussed all this. Okay, pinholes, thickness of pins, thickness of protractor. Learn all of these. Make sure you know all of them. Okay, now, these experiments, I would like you all to go through it yourself. Try to attempt it before reading the answers. Okay, because most such type of questions we've discussed. Look over here. How can you check the temperature stir before reading? Wait for it to rise. We've seen all of these questions. Okay, so I would like you all to go through these. This is plan and experiment for the spring. For the spring, okay? The spring must be wired, repeat, what is the procedure, what are the precautions, all that. Because it's easy, you have already given the tips. Make sure you write all of them. Proofread your answer after you're done if you have included all these tips. Now we will be on these bullet points, okay? Now we will be discussing some last minute tips for paper 6, what you all can do in the time that is left. Okay, so here are some last minute tips. Okay, last minute tips for physics paper 6. Okay, with the time left, how much time you have, what all can you do to score good marks? Okay, first of all, I want you all be chill. This is not the time to stress out. Don't stress out. Trust me, you all will do well. If you all stress out, you will mess up your paper. You will go in the exam hall thinking you will blast the paper. Okay, you're gonna bomb the paper, you're gonna cook. Okay, don't worry, blast the paper. You know, you get what I mean by blast the paper? It's cook in the paper. Okay, cook in the paper. You all got this. Now, first of all, go through guidelines. Go through my guidelines video. Go through guidelines. This video has all the experiments. The previous video is also very helpful. It has all the guidelines. I'm going to the PDF by Basumitra. If you're lazy, you can't read it yourself, just watch that video. You're all set for the paper. Those 1-2 marks questions which annoy you, you will not suffer in all those. All right, so go through these guidelines, go through both the videos very well. Do the most recent paper. What's the most recent paper? Do Feb March. Okay, so do Feb March 2025 paper 6. Okay, for these two things, watch my video, because I have done I have made 2 videos, 3 videos, 2 videos for guidelines, 2 videos, and 1 for this. Okay, you can watch that. But for this, for Feb March, okay, for this Feb March, first, oh shit, what the heck? Okay, for Feb March, I want you to do it yourself first. Okay, put a timer of 1 hour, do it yourself. Do not check your marks. Okay, do not check your marks, just do it. And then you can go through, watch my video and just go through your mistakes. Don't start marking your paper like an examiner. This is not a good thing to do before your exam. You will lose motive. So don't mark papers. Do papers. I don't say don't do papers, but don't mark them. Don't mark those papers. Don't check your marks. You can do papers one day before exam. Don't mark those papers. Okay, you can put time and do it, but don't mark those papers. Oh, I lost 1 mark here, 1 mark there. Because exam is all about your strength, how much motivation you have. If, God forbid, maybe because of your carelessness, your silliness, you get low marks while practicing, so it will make you lose your motivation. All right? So now, next tip for you all. These first of all, be chill, blast the paper, you will cook it, trust me. Okay, go through the guidelines, the 2 videos I've made. Do Feb March 2025 paper. You can watch my video if you're too lazy to do it. It's better if you do it with a 1 hour timer. Okay, don't mark papers. Go through, if you don't have time now, because time is very little. If you didn't do any past papers, chill, watch my video, trust me, it covers everything. This video and the previous video, it covers everything you need to know for paper 6. Okay, go through. If you really want to do, okay, you can go through past papers, okay, MS. If you don't have time to do past papers with 1 hour timer like it is done and you didn't do any, what you can do is open the question. Okay, so you can open the question paper at one side and then the mark scheme at the next side, and you can go through one question, read all the questions, think what you think the answer will be, then read the mark scheme. This is a very good technique. You can skim through them basically. Okay, then another thing which I want to tell you all is for the graph, choose good scale. Okay, choose a good scale. And you know, if you're slow in doing the graph question, I would suggest you all to come back to the graph question later in the end. First solve the whole paper. Okay, so first do all the questions and then come back later to the graph question. Okay, because if you take a lot of time on it, because yeah, choosing scale and all, marking the points, it can take a lot of time. Then next thing, many people think that when you draw the graph, like you get points, right? When like if you get 3 points like this, do not extrapolate. Do not extrapolate the line. Okay, do not extrapolate the line unless asked to. All right, you not extrapolate the line unless you're asked to, because in the candidate responses, all of the students have not exceeded the line. Like extrapolate, by extrapolate, what I mean is you extend this line and you make it touch the axis. Don't do that. And take care of the scale if it is 0,0. Okay, if they say start at that or don't start at that, okay, take care of that question. Read question really properly and do not extrapolate the line unless you're asked to. Okay, and And yes, for the gradient, when you're drawing the line, if you're asked to find the gradient, try to draw a triangle as large as possible. Okay, and sometimes what they do, triangle is like this, okay? You draw a triangle as large as possible. Sometimes what they do is they're like, drop a line from, okay, wait, first let me write here, draw triangle as large as possible. As large as possible. Okay, you'll draw the triangle as large as possible to use, oh, okay, to find gradient. My god, my handwriting. Okay, wait, to find gradient. I hope you understand my handwriting. Actually, I don't think so you will do. Anyways, okay, so next thing what you have to do is, for the graph, yeah, what was I going to talk about? Yeah, sometimes what they do is they are like in the graph, find when the load is, for example, like when the load is 5 Newton, what is the extension? Okay, so that time some students, they mess it up and they draw a triangle. That time you just need to draw a line which touches the axis and check what is the point over here. Read across and check what is the point over here. Okay, so that's all I wanted to tell you guys. I hope you all must lock in now. Watch the videos, watch all the 3 videos I have made for physics 10 now. And then after doing that, lock in, start going through mark schemes and question papers. You can read the question, check, think the answer, go through the mark schemes. Trust me, you all will do really well. Best of luck and many good wishes to you all. Let me know how the paper goes. All the best and goodbye. Take care. Don't stress out. You all will smash the paper. Trust me. I have gone through both the resources which I think are the best resources and very helpful. The guidelines for physics paper 6 and the Vasumitras. Okay, they are really helpful. Every student must be knowing about it. Share it with your friends so that they can do good paper. And if you are sitting in the exam hall, God forbid, you're not able to answer any question. Maybe their prayers help you. They saw that paper, they prayed for you, and that time God can help you. Not trying to emotionally blackmail, but yes, that's what I think you should. And yeah, do subscribe my channel. Take care. All the best. Goodbye.